myself. There we go. Okay. So that's, the recording has started. So we're going to talk about the greenhouse effect. Does anyone have an idea of what the greenhouse effect is? Anybody? Nobody? What does a greenhouse do? It traps something, traps heat, yes.
Yeah. So that it works like the sun. Yeah.
Yeah. Also, I would recommend pulling your notebooks out. If you do not have a notebook, I can provide paper for you because I am a gracious God. I have paper right here. No one should have their laptops open. Everyone should have a notebook for taking notes. If you do not have notebooks, I have note paper right there. I also have pens in that container up at the front. Schaefer? What? Some coffee? No. Okay. So, let's talk about the greenhouse effect. Okay. So, what does a greenhouse do? Retains heat, yeah? Dollar?
Isn't the greenhouse effect like the gases like go up and they just trap all the heat on Earth, and that's why like global warming is like a big thing. It's because of the carbon something problem.
Yeah. So, yeah, we'll talk about climate change in a little bit. Yeah, kind of. So let's talk about it. All right. So the greenhouse effect, the real gist of it is that the atmosphere retains heat. Okay. It holds the heat in. Ever so slightly. Okay? So the atmosphere retains heat, it holds it to the earth. And let's explain how that works. I like to think of the greenhouse effect kind of like a hot car. Sometimes I call the greenhouse effect the hot car effect. Okay? Which I think makes more sense because we experience cars more often than we experience greenhouses. So prepare yourself for a beautiful Mr. Croshaw drawing. The atmosphere retains heat. It's 4 words. Okay. Prepare yourself for a beautiful drawing, everyone. Oh, wait. Yes. Okay. All right. So we've got this car here, and trust me, it's gonna be beautiful. Oh yeah, here we go. Oh yeah. Gorgeous. Oh yeah, this is a hatchback, by the way.
That's actually decent. Although those wheels look a little
Okay, where's the shocks? I don't see any axles, Mr. Croshaw. All right, so this car has some windows, yeah? Oh yeah, that's some gorgeous stuff right there. Okay, so this car has some windows. And what happens is we have the sun here, which the sun is not yellow, it's white, but whatever. We'll let it slide this time. And the sun's rays come in and they go through the windows. Okay? And if you can't tell, this is the front of the car. I know it's very confusing. This is a bi-directional car, okay? It can go either way.
It's a truck.
Okay?
It's a truck.
So it goes in to the light from the sun goes into these windows, and it hits the seats, and it hits the dashboard, and it hits the steering wheel, all this stuff that's in here, right? Well, the light comes in and passes through the window, no problem. When it hits the dashboard, let's say it's a black dashboard. Is a black dashboard going to have high albedo or low albedo? Low albedo, right? It's going to absorb most of the heat. A little bit of the energy will get reflected away. Reflection. Okay? Reflected away. But the majority of it gets trapped inside the car because it hits the steering wheel, it hits the dashboard, and it becomes heat. And all that heat gets trapped inside the car. Okay? So the greenhouse effect, again, I like to call it the hot car effect because as you all have experienced when you're walking out to the car and it's been in the parking lot of PetSmart,
Hopefully no one's talking it.
and you left the windows closed and you have some nice roast beast in your car by the time you get, no, I'm just kidding. That's kind of gross and dark. No, there are no living things. Okay, but it gets really hot in the car really fast with the windows up because, yeah, melted crayons. And this year, with everybody having a whole bunch of hand sanitizer in their cars, there were more than one case of hand sanitizer exploding and lighting on fire in hot cars. Yeah, so don't, yeah, anyway. So the heat builds up inside the car, right? So the glass window allows the air to come in, or not the air to come in, allows the light to come in, but it doesn't allow the heat to escape, okay? That's the same thing that happens here on Earth. So beautiful Croshaw drawing of the day, number 2, okay? So we have the surface of Earth here, and we have the atmosphere.
And we have water, thick layer of water.
The atmosphere here, and then the sunlight comes through, okay? And a portion of it reflects away out back into space. Again, that's reflection, okay? But the majority of it, especially if it hits like soil or asphalt or dark rocks, gets converted into heat energy. Yeah, Dahlia.
That's why like the glaciers is the closest to be deal because they help turn stuff the light back out.
Right, and so ice helps to reflect the sun's light away from the earth and not heat the surface. But what happens is the majority, this area gets hot, right? This area gets hot and that heat rises, okay? That heat rises through the atmosphere and some of it escapes back into space. Some of it escapes back out into space as heat, but a lot of it gets trapped by particles. And these particles are what we call greenhouse gases. Greenhouse gases. Okay. So a greenhouse gas is a compound in the atmosphere. that traps heat. Let me expand this a little bit so it's not in our drawing quite as much, okay? So compound in the atmosphere that traps heat. So does anyone know what the majority of our atmosphere is made out of?
Isn't it like nitrogen?
Nitrogen. About 80% of the air that you breathe is nitrogen.
That's a living bomb.
What?
I was making a stupid joke and saying the living bomb.
No, we're not living bombs. Nitrogen does not react with much. So nitrogen is the majority of the atmosphere. It's about 80%. About 19% of the atmosphere that we breathe is oxygen. Okay? The other 1% is other stuff. Okay? Some of it is carbon dioxide. Some of it is water. Some of it is methane. Some of it is argon, neon, krypton. Okay? These other gases. Yeah.
What's the argon?
Argon is a noble gas. It's a heavy gas. Yeah. It's on the very right side of the periodic table. It's called AR. It's atomic sign. The what?
You say crypto?
Krypton, Kr. So AR is argon, krypton is Kr, xenon is Xe, and radon is Rn.
Neon is over above it.
Neon, yeah, and then helium. Those are the noble gases. You'll learn about them in chemistry. Anyway, when you take chemistry, says chemistry teacher. Okay,
Seriously.
I like physics. All right,
It's terrible.
so the greenhouse gases trap the heat, okay? Examples of greenhouse gases. So in our atmosphere, there are lots of different kinds of greenhouse gases. Greenhouse gases. We have methane is a very strong greenhouse gas. Water is also a very strong greenhouse gas. And carbon dioxide is a very strong greenhouse gas. Okay, so these trap heat. In the atmosphere, and we will talk a lot about climate change. And the big thing with climate change is carbon dioxide. Okay. The big thing with climate change is carbon dioxide. I did not mean to change the entire thing, but whatever.
Don't we just like make Kirby and told you to hear her?
If we what?
Just come in here and hear
I cannot hear you.
her.
Okay, so we'll talk a lot about carbon dioxide, but and the greenhouse effect. That's for a later day when we get to discussing climate change.
We get Kirby to suck up all of the carbon
Kirby.
dioxide and,
Yes.
So you want a fictional pink balloon character
yes,
to suck the carbon dioxide out of the air.
yes.
Really?
Sounds like a great idea. Okay, so the greenhouse effect is really important. Without the greenhouse effect, we would all be dead. Okay, but people are like, oh, well, what about climate change? Climate change is bad. That's true. Climate change is not no bueno. However, greenhouse effect
You know,
because possible. There we go. If the greenhouse effect didn't work, if the atmosphere, so for instance, nitrogen is not a greenhouse gas. Oxygen is not a greenhouse gas. If the atmosphere was completely made out of nitrogen and oxygen, nothing would be alive. Because every night the Earth on the night side would go down to negative 100 degrees Celsius. Okay?
It'd be like Newton stuff, like.
Yes. Yeah,
the
it
plants are, like,
would get really
hot
hot on one side
and really cold.
and really cold on the other side.
There's no like regulation temperature.
Right. So the atmosphere holds the heat during the night. So it's really important. Okay? If the atmosphere didn't hold heat during the night, again, it would get unbelievably cold when the sun sets. And we would all be in a very serious pickle.
The earth already doesn't hold any heat in.
But what?
The moon already doesn't hold any heat in. 102 minute blankets every night. Even
Yeah.
in the summer.
So obviously the Earth does get colder at night, but again, if without the greenhouse effect, it would get extremely cold at night. Okay? So, and I want you to, this isn't like an assignment or anything, but I want you to start noticing the temperature in the morning and the conditions of the sky, if it's cloudy or if it's clear. I bet that you would think that it would be colder on cloudy mornings. It's warmer during cloudy mornings because the clouds hold the heat in. Okay, so when you wake up and it's really clear outside, or at night when it's a clear night, it will be colder than a cloudy night because the clouds act as a blanket. Not anymore, there's a blanket. Okay, that cloud acts as a blanket to hold the heat in. Okay, so the greenhouse effect, we will talk about climate change and its dangers, but we have to acknowledge that without this heating effect, we would all be dead.
Yeah.
Okay? So that's the greenhouse effect for you. Again, I like to call it the hot car effect. All right? We are going to talk a little bit more about, I'm going to introduce the idea of like latitude and longitude and how that affects climate and so forth. But we need to get into another topic really quick, okay? And that topic is weather versus climate. Okay? So we're going to do this really quick, and then we're going to do an in-class assignment that will take you a few minutes. So hang in there. Weather versus climate. So what do we understand about weather and climate? What is, well, first of all, what is weather? I mean, we talk about the weather all the time. Who could give me a definition of weather? Anyone? Yeah, you want?
I can't give you weather, but I can give you climate.
Okay. All right, I guess I'll just move this over here. Climate. What's the definition of climate?
Long-term weather conditions over an area.
Good. Long term. And I'm not going to use the term weather because that's in our definition or what we're trying to define, right? So long term atmospheric conditions and I like that you said in an area, and I'm going to use in a large area.
Yeah.
Okay? Area. Long-term atmospheric conditions in a large area. All right? Weather. How would we define weather? It's something that we talk about all the time, but can you define it?
Short-term version of climate.
The short-term version of climate. Okay, yeah. So I think that's a pretty good way to put it. Short-term term atmospheric conditions, atmospheric conditions over a small area. Okay? Here and now. Okay? It is here and now. Weather is what is happening in the atmosphere. Is it raining? Is the sun shining? What is the temperature? What is the humidity? That is weather right now, right here. Climate is different. Climate is everywhere. Where? And I wouldn't say always, but like often, that's a good one. Okay? It's more of an average trend. Yeah, tell you.
So like climate would be like Washington is rainy, right?
Washington is rainy. Yeah, that's a pretty good, I mean.
Versus like weather would be like it's raining right now in Washington.
Right, yeah, so we can say, because weather can change multiple times in an area over an entire day or over a week, right? If we want to talk about climate, we don't talk about climate here and over the past week. We need to talk about climate over the past 3 years, 4 years.
It's like when you see like they have like these like things where they'll do like the average temperature,
Right.
like during summer or like winter in certain places.
Precisely. So we need to be able to compare. We need to be able to compare the average temperature over this large area over a decade, right? Over 10 years, or how much rainfall there is on this continent for the past 50 years, right? As opposed to, well, this year it's been kind of rainy, right? Like, oh, the past few weeks it's been really rainy. That is weather. Climate is a different thing.
I feel
Okay.
like I think of like the difference I think of weather is like sometimes and climate is like usually.
Yeah, exactly. So climate is an average or a trend. Weather is variable, okay? It changes, right? It changes quickly, and it's instantaneous. It's only right now. Hayden? Sorry, Ethan, sorry.
Staff didn't say, where is over there?
No, that's fine. Okay, so that's what I want you to do. We are going to take some time to do an assignment called weather or climate. And I'm going to stop the recording here. For those of you at home, do the weather or climate assignment. Like and subscribe.